Hello, this is our second integral calculus partial project, and it's about areas, and our team is conformed by Yoshio Takaki, Scarlett Cruz, and Hector Durantes, and let's go. In this graph, we need to calculate the function that is sine square of x, and the problem states that there are two vertical axes in respect to x that are 0 and pi. So now that we imagined the lines, we know that we have to calculate this and draw and imagine a rectangle that is inside of this function and calculate this area.
Okay, our problem is integrate of sine square of x times dx. So for that, we have to find an identity. So we find the trigonometric identity that it's 1 minus cosine of 2x over 2. So once we have that, we can integrate it normal. So we have the integrate of 1 minus cosine of 2x over 2 times dx. So for that, we can take out of the integrate 1 over 2, and we continue with this. So we have 1 over 2, the integrate of 1 minus cosine of 2x times dx. Then we can separate this part, so we can have 1 over 2, the integrate of 1 times dx, minus, we respect the sign, the integrate of cosine of 2x times dx. For continue, we have to use the first theorem of calculus. So then we have that 1/2 of the integrate of 0 between pi times dx minus the integral of 0 between pi cosine of 2x times dx. It's equal to 1/2 of x between 0 and pi minus sine of 2x over 2, the absolute value of 0 between pi.
For continuous 1/2 times p minus 0 minus the same, but only share the x for pi, and minus the same, but only change the x for 0. And this is 0 over 0, 0 over 2 is 0, and this is sine of p is 0, and the answer of area is, and the result is pi over 2.
The application in real life of these kind of problems are varied. For example, in physics, we can use this to calculate the change in a velocity that is between 2 points of time. The area that we obtain represents that change that we wanted to know at the beginning. Another situation would be when a tank of water is being filled, and the area under a curve is useful in this case to see how much water increased during a period of time. And in this kind of problem, we can establish boundaries that we would consider as a waste or as a minimum quantity that needs to be filled. Areas under a curve are also useful in economic phenomena because we can know the profit we are obtaining from something or the total amount that consumers are willing to spend. Another incredible use of this type of problems is the analysis of data and statistics for environmental sciences. For example, we can know the density that the weather is going to have during a week. To sum up, we can conclude that this will be very useful in our university period because it will give us a tool to solve advanced problems that need reasoning and precision.